Good evening, everyone. My name is Reshma from Skyy Rider Institution. So today we will just using a new topic, and all of you know about little those who know uh, know the SolidWorks, and nowadays it's worldwide and using
Mm.
the electric vehicles. Okay, so we just using the electric vehicle, how to design electric vehicle. So before that, we just know about what is the use of electric vehicle and how it will be affect in our market and the marketing strategy, what will be the requirement for this, and what will be the processes to making a electric vehicle. So now today's topic is electric vehicle three-wheeler chassis design and go to the marketing strategy. Okay, now today's objective is this one. So how to make three-wheeler using SolidWorks. We will design by the help of SolidWorks software, and then we are know before that, and using the SolidWorks, we just know about what will be the approaching for the to making the profile, and next is will be the competitive emphasis. Now see, first of all, we just know about little bit about our SolidWorks. Okay, so first one is a high end software. The SolidWorks is a high end software. So there are three a hello. Okay, so there are three end software: high end, mid end, and low end software. There are three.
ఇది
Please,
కాల్
please mute
చేస్తున్నాడు.
yourself.
అదే క్లాస్ వింటా వేరే క్లాస్ వింటున్నాడు.
Please mute yourself. Okay, so SolidWorks is a high-end software. There are three ends softwares are there. High-end means three things will be there: CAD, CAM, and CAE. And low-end means it will be adding only a single uh, workbench will be there. CAD will be there, and the mid-end means any two CAD or and CAM. Any CAD CAM on CAD CAE, any two workbenches will be there. So that is a mid-end software. So SolidWorks having a nowadays SolidWorks updated versions having a high-end software because CAD CAM and CAE is available. So that's why the high-end SolidWorks is a high-end software. And next point is a SolidWorks is a feature based software. That feature means whenever we are making something, some features are required, some where your profile will be easy and effectively and efficiently you can make your profile. So that's why it is a feature based feature based software. All the features required features are available in SolidWorks software. Next point says that fully parametric software. It's a parametric software. Parameters, length, height, width, you can change at any time. So that's why it is a fully parametric software. The next is a fully associative software, and the fully associative means whenever we are using part workbench, assembly workbench, and drafting workbench, all three workbenches both are associative to each other. That means whenever making something part design and making some components, and whether we are going for the assembly, that mating components is not by mistakenly is not fit together, and some components is required to modify. So no need to go to again to create your part and to make and again go to assembly. No, you can directly use the part and just modify that component, and automatically will update in your assembly. And same way, if you modify something in an assembly, automatically update in your drafting sheet. So that's why it is a fully associative software. Both are associated to each other: part to assembly, assembly to drafting, part to drafting, assembly to drafting, each of them to associate to each other. And the last point is not the least, the boundary representation based software, that b-ray based software. That b-ray based software means whenever we are making this profile, by the help of edges, vertices and faces, you can make the, and you can take the reference and you can make the profile as for the requirement. So that is a, if someone saying what is SolidWorks, then you can say this kind of and this advanced and this attractive points you can say. And then we are going for the next slide, why we prefer SolidWorks software. uh, okay, so it's a user friendly software. Anybody can manipulate this software easily, so that's why it's a user friendly software, preferable by the beginners, and both not only beginners and some experience holder as well, using, and you can they can manipulate the SolidWorks software, because SolidWorks having some advanced and some features where the beginner can easily learn, and where the advanced features are available, so the experience also uh, take the advantage from the SolidWorks software. So that's why it's a user friendly software and preferable by the beginners. Very easy. Whenever you learn the SolidWorks, so you will enjoy the SolidWorks software. And the next is a next point, whenever we are going for the makings and to learn something, and we are using for the future reference, and nowadays the aim will be your to get place a good company. So these are the notable company where the SolidWorks is used there, and these are Volvo, Alta Motors, Toyota, Cherokee, Air Liquide, EAD Aerospace, Aviation Facilities, uh, L&T, Tata Motors, AP Racing, and Volvo, Toyota. These are notable company. No need to explanation why it is uh, notable company. Alta Motors is American manufacturer company where they are made the sport electric motorcycles, sports electric motorcycles. And then is a Cherokee where and which is manufacturing the luxurious SUV, and Air Liquide and EAD Aerospace. These are the aviation companies where they are using, no sorry, Air Liquide is a gas technology, uh, is a gas technology company. EAD Aerospace Aviation Facilities, both are aerospace company where the aero modelings are using there. L&T, Tata Motors, all of you know the Tata Motors, L&T, and the AP Racing, which is where the most expensive car is a Ferrari. Ferrari braking using manufactured in this AP Racing company. Okay, so whenever you will be pro in the SolidWorks software, that you will get the chance and you will get this company. Okay. Now, the next slide is a little bit about the chassis. We are using SolidWorks, and using the SolidWorks, we are making the chassis, electric vehicle chassis. So just know about the little bit about the what is the use of chassis, work of chassis, how does it works, and how it will be applicable. So now the chassis is a main part of the structural frame of an automobile, any kind of automobile, not only electric vehicle. You can use car, truck, bike, cycle. Everywhere the chassis part is very important for the automobile. And the next is a why it is necessary. It connects all the key components, includes suspension and drivetrain. So it will be, it's hold all the things. If your chassis is sustainable, it will be sustain all the things including suspension and drivetrain. Suspension and drivetrain is the most uh, important thing in our vehicle. So it will be it will be holding and sustain the suspension and the drivetrain. That means your whole vehicle will be manipulated, that depend upon your chassis. And next, uh, there are five main functions of the chassis: to provide an area for component and luggage for safety to the occupant and outside part, parts. Provide points for mounting of suspension, drivetrain, and provide. Please mute yourself. And provide a stiff framework linking all mounting points. Then, next point is m- the mounting components must be rigid. A large movement may cause component to interfere, and thus not function intended. So that should be a rigid. A large movement may cause components. So it's very important part, which is should be rigid moment and should be contain uh, all the required things. Then next point is says that this section covers the function of a chassis, the different types of chassis from the review. A suitable chassis for electric vehicle will be designed. That depend upon the classification of the vehicle, where it will be commercial, where it will be a loader, where it will be a any other purpose. So that depend, and whenever vary the vehicle, it car, truck, electric vehicle, so that depend upon the variation of the requirement. Next, we just know about what is the use of the chassis. How does it applicable for our requirement, and then just know about the what kind of chassis is uses there. So conventional chassis, there are two kinds of chassis are there. One is a frame chassis, frame full chassis. Another one is a frameless chassis. You can say in another way and in a good way, as a designer and as a manufacturer, you can say conventional chassis and non-conventional chassis. What is the conventional chassis? Convention means it will be a workpiece and your cutting tool, both are directly contact to each other and removing the material. That is the meaning of the conventional machining. Here it is retain the conventional chassis. That other way you can say full frame chassis or frame full chassis. In this type of chassis, the body is made as a separate unit and joined with the ladder frame. So that chassis will be a look like a ladder, and your body will be joined there. The both body and your chassis both are different, and we are joined together and we are made together. That is a full frame chassis. And the frameless chassis, where the body is act as a here with the help without the help of the ladder frame is absent, and the body itself act as the frame. So body is act as a frame. It supports all the loads, but where in a full frame chassis, in full frame chassis, the board chassis is sustain all the load of the body and other things. But here frameless chassis, body is act as a chassis, and it contains all the loads. Now see, this one is a frame chassis and this one is a frameless, where there is a no chassis, no chassis. That all the frame is and the total body is work as a chassis. It's loaded all the things upon a body. But here chassis loaded will be upon a chassis. Next, here So today we are just using the ladder frame chassis. Why we are considered the ladder frame chassis? The ladder frame consists of two longitudinal beams. Why I'm saying two longitudinal? It's a ladder frame. Ladder means there are two beam. There is a two longitudinal beams and with multiple cross members joining the members. It's looking like a ladder. It is very versatile as allows uh, virtually anybody shape to be placed at the top, placed atop the chassis. Is versatile. Is versatile. You can take any kind of shape. There are different shape. If you are going for the shape, there is a joggle shape. There is a ladder shape. The different shape will be inside of the chassis. Then the ladder frame chassis as shown the previous slide, which is durable due to its simplicity. It's durable due to its simplicity. So only it's a you have to make a ladder like a profile. So it's very durable. So that's why we are using and electric vehicle making by the help of and using the ladder frame chassis. And now as you can see. Here, there are three-wheeler vehicles where the chassis is like here. So here, it's the chassis is clearly visible. So this is our chassis. So here is a loader. Here is a commercial. So this kind of there are variety types of uses. We just mention here only a two vehicle, but nowadays for the requirement for the variety of the purpose we are using different kinds of model and different purpose of the vehicle. So not only it's required the chassis body and just know about the chassis, but there is a calculation whenever we just making some vehicle and that is required some calculation where the required some length, width, height, and some where the motor, battery, gear, clutch, speed, gear, which is important for the requirement, and that wheel radius and the ground clearance is very important whenever we are making a chassis, and whenever we are making the wheel and wheelbase. These are very important things, and fuel economy is very important when we are giving the rpm, and some calculation is required some for the what will be the load, if the load will be this much, and what will be the resistance power, what will be the braking system for given load, and what will be the uh, maximum speed, what will be the capacity, acceleration. So these are the things we have to calculate, then we have to manufacturing and we have to design it. And here as well it has mentioned some kind of here specification is motor type is a dc motors, what will be the, yes, that load will be depend upon your power, and power what will be the voltage of the battery is using there. So these are very important things. So we have to make sure your profile, and uh, that should be very important whenever we are making chassis and to making a full vehicle. Now, not only you can't random make any you can't take a startup with the help without the help of certification. That certification is very important. So whenever we are uh, going to ride a bicycle or going to ride a what motorcycle and any two wheeler, that is required some rules and regulation. That rules what, you should be above 18 year, you must have driving license, you must have insurance. So these things are nowadays very important whenever we are going to ride any two wheeler. Only that's a small epitome of the certification, which what will be the requirement, rules, regulation to ride a bike ride a bike. Here it's same way. Certification approval, whenever we are making all the things calculation, all the things are okay, but that the certification is very important. From where? International center of center for automotive technology, that is in short you can say ICAT. And ICAT has a facility for vehicle homologation, and also testing laboratories for noise, vibration, and harness, that NVH. And passive safety, it also includes the powertrain laboratory, engine dynamometers, emission laboratory with Euro V capacity, a fatigue laboratory, passive safety laboratory, and vehicle test that ICAT is also being developed as a center of excellence for component development. And NVH, noise, vibration, and harness. So this company, and it's a government approval, which is a government approval is required to make and to, please mute yourself. Its government approval is required uh, to uh, ride your vehicle in your road, in your NH. So that certification is required from the ICAT. And another is a ARAI, Automotive Research Association of India, where the same way this also giving the approval certification, where will be the testing, which kind of testing will be there: product design and development, evaluation, automotive equipment, and standardization, technical automation services. So these kind of things are giving here. You can say this one is a industry, automotive industry, with the Ministry of Industry, association by the automotive industry with the Ministry of Industry, Government of India. Please mute yourself. Okay. And the application, the modern technology, and the conduct specific tests. So these tests are approving if it is okay, then this government approval certification is very important whenever we are launching the vehicle in a market. So now your profile will be easily uh, launching in your market. So this certification is very important. You should, if you wants to make a profile vehicle, so that certification is very important. And here it has added some steps in the vendor selection process. So not only it's required the certification, also vendor selection. Please mute yourself. Okay, so here steps in the vendor selection process. The first one is you should know about the software, then where we are designing, then you should know about what will be the calculation to make a profile, to design a profile. And after that, if the basis on your designing and your analysis, your vehicle is ready, but that vehicle is uh, not accessible to for the market, to launching the market, you should take the permission to test for your vehicle from the ICAT and ARI. Then, and that is not sufficient, you should take the vendor selection. You should take the, if you wants to take a startup for the electric vehicle, so this vendor selection is very important. And what are they? Consider using an e uh, procurement system. Determine product and vendor requirements, and prepare RFI, RFQ, RFP to solicit bids. These are the tender. Solicit bids are the vendors. So where? So these three are RFI, RFQ, and RFP, where you have to you have to select it. That means your qualification as owner and as a vendor bids as a tender, how the tender will be passed. Your uh, tender holder should be having um, a qualification, some marketing knowledge and marketing relation should be there, and some strategy should have. And so these kind of, just a minute, I'll just explain, then will at the last I will ask you. Okay. So these are the process where the vendor will be selected. So where you as a vendor hold your uh, tender holder, is it uh, when someone, and not only a single man is applying the tenders, there are lots of tender holders are applying the vendor selection. For from them, if the 100 of the peoples are applying for the vendor selection, and then the RFI will be uh, selected from 100 to 10. Then after then RFQ and RFP, that processes uh, and the qualified things are selected. So after that, these processes are required for the vendor selection. This little bit three processes. Then then they also giving, so these uh, three things are allowed for the searcher: company approval, list, vendor, and vendor evaluation. They will evaluate your vendors, identify your potential vendor to get. What I'm saying here, so same thing is written here: identify any other potential vendor to get, refer your company, that is your relation, company vendor selection criteria list, company policy, and they will shortlisted you the vendor as, as the most qualified. If you are qualified or not, who is the most qualified, who having a most knowledge about these vehicles. So these things are very uh, required. And view demos, meet potential vendors and vendors for large purchase. Then obtain multiple customer reference and read any relevant case study on the vendor website. This also required. Get financial stability potential vendor and suppliers. Negotiate term, win the price, discount, and delivery dates. So these are things will be negotiable or not. Contacts with winning vendors selected. So these are the processes following. Then you will get the vendors. As a vendor you will select it. So these are the process. Next, now we are going to use make a profile where using the SolidWorks software. So this is the profile where we are using the uh, uh, solid chassis to making by the help of SolidWorks software. Hello, my screen is visible to you. Two screens are visible to you.
Yes, ma'am.
Yes, ma'am.
Oh, okay. So now as you can see why I'm using two screens, so it's useful. So here this one is a wireframe and the drafting sheet. It's a blueprint you can say. So where we can easily use our chassis. So whole vehicle is not possible here to make here in using in this session. So I'm just using how to make a chassis. How to make a chassis, that is chassis also very important to make a vehicle. So one by one you have to make one component. So I'll just taking only a chassis here. So these are the chassis. So we have to make a chassis here. So we have to read it first. So please mute yourself. Okay, so now this is your chassis. So these are the projection view of the chassis. So where we can get the actual size and actual shape of the profile. So if this is your chassis and this is your top view, when the top view we are making from the top view at a time, we are making a top view and this side view as well. So it will be easy to quickly make your chassis. So let's see to make this one. So now, okay, okay, so let's make it. So here we are having the interface of the SolidWorks software. SolidWorks software. There are lots of things are there. We can use the features. So those who know the SolidWorks, it will be easy to access these features. But here is a advanced thing is a weldment option. We are using the weldment. By the help of the weldments, we will making our chassis efficiently and quickly. So let's see. So for that we are making at a time front view and the top view. So how does it work? So here if we are taking a sketch, it will be we are making only a 2D, any x y y z z x plane, any one plane we are consider. But expand this sketch, there is a next is a 3D sketch is there. So let's go for the 3D sketch. So now my origin will be looking like this. So let's click on that. I'll just making a profile. Okay, I'll just making a rectangle, so it will be easy to take a relation and to make a constraint. Okay, constraints also very important. Where we are using any software, the constraint is very software expect except uh, AutoCAD and other softwares required constraint, that is very important. Okay, so now I'll just making a this kind of a profile. So here, so let's go to minimize my, and now see, as you can see, here is my profile. Now I'll just making a this top one. Okay, this top one, we are not making this cross section, this width of the profile, only we are making the 2D wireframe. Okay, so okay, so for as you can see, when I'm just moving, please mute yourself. Okay, now as you can see here, we are having a profile which is rotating a freely 360 rotation like this way. Anywhere it has taken, but it's not a considerable, because if we are making something, it will be taking our time and your work profile is not taken. Okay, then what to do? So let's go for here. Okay, so now this is our profile. So here we are giving constraint. So blue color is the under constraint. We have to constraint to restricting the degrees of freedom. Select on that, and here is a along axis. We have to restricting the degrees of freedom along this axis. So which is required? I'll just giving this x axis along the x axis. This should be uh, considerable. Okay, and this also I'll just taking by the help of y axis. So let's click on that and go for the y, and now it has taken. Now see, is it movable? Is it movable? No, it's only reducing, increasing the size of my profile only. Okay, then one by one we have to restricting the degrees of freedom. So by the help of smart dimension, we are giving the dimension here. Just click on that. Okay, and how much the distance is it? So you can take it from here. We are making this much only. So this distance is 2010. So you can take it. Okay, now as you can see, it has converted into a blue color. So now these degrees of freedoms are restricted. I'll just taking this one to restrict these two sides. And what will be the width of it? So it's a 655. So you can take 655 into. Now see, it's a constraint and all the degrees of freedoms are restricted. That blue color means all the degrees of freedoms are restricted. Okay, then we are using, these are lines, these are supported frames, we have to make it. So let's make it. So I'll just making a top view. I'll just pressing the control 5 for the top view. So it will be easy. Sorry, control 2. Okay, so now this one. Okay, let's go for your to make it and go for take a line. This one. Okay, how many lines? One, two, three, 4 lines are there. So let's make it 4 line and select again. After that we are restrict. And this length is, last length is 125 from here to here. So let's give it 125, enter, and from here to here is 543. So just click it 543 and okay. And next same 543, give it from here to here 543. Okay, this one 548, select on that, and this one take it 548, 548. All are my units are mm. Okay, so just go for it. Now done. Okay, 1 2 3 4, 1 2 3 4. But this one is a unwanted, but it was taken for the reference. Okay, you can click on that. It will be appearing at this kind of, uncheck the smart dimension. Okay, just expand it. So this is my specification tree where you can give this one only for the reference purpose. I can't delete. If I'm deleting, then my constraint will be disappear and uh, it will be vanished. So I'll just using the for constructions, only construction, my constraint will be there. Okay, now it has done. So you can directly make this profile here. So let's go for your, please mute yourself. So mark it here. You can mark it here. 1 2 3 3 number 1 2 3. Then you are making here profile only for the this one outer side, outer part. Externally we have to make it. So you can take it reference from here. Okay, take it and then make it constraint, which is given 355, the width of it. Select it 355, 355, enter. Then we have to give this total length, which is given here. This one 975. So just take it from here to here. It's 975. 975, enter. Okay, so here, as you can see, it's overlap here, so it's not should not be overlapped here. Okay, just zoom in, just drag it outside. Okay, so I want to take this one central, so just you can go for the create a center line, select the center line. Okay, and let's make it horizontal x along the x direction. Now it's fully constrained. You can take this one, press control, this one, so it will be a coincidence. Now as you can see, both side it will be a, and here, but still is under constraint, still is under constraint. Both sides are centralized here, but it still is not considered, so it's not restricted. I'll just taking a distance from here to here, it is given 50, and let's click on here and just click on here and give it 50 and 50 and okay. Okay, still under constraint, so let's check it. Okay, let's check it. This one should be aligned, so you can take it in a x-axis, so let's give the x alignments. Okay, control Z. Okay, I'll just making these two as a parallel. There is a lots of way you can restrict the degrees of freedom. I'll just trying the parallel here. Okay, still it's not constrained. Control 5. Okay, go to smart dimension. Again, I'll just giving the dimension from here to here. Okay, it's not taken under. Okay, let's delete it. Which one is not taken? Okay, only it will be taking a time to constrain to make the profile. Only here, only taking a time. Okay, so again, give the distance from here to here and give it 50. Okay, make it here. This one 355 and this total distance is 975. Okay, I'll just taking a Y. I'll just taking this one X along. Okay, now it's fully constrained. Okay, so now it has taken, but these things is not required here, so we have to trim down. So go for the again control 2 or 3. Okay, control 2. Just trim the unwanted things, only this one here, this one here, 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 only trim it. Now done. It has done up to this one. So now we are just making this one. Okay. Okay. So if I'm taking this one, we can make it. So it will be easy if I'm taking control 4. Expand it. This side is required, no? Okay. Okay. Done. Then let's make this side here. This one. So I can take it. This one to make a line. And this much is required. Then give the distance which is taken here. And you can take from here to here is 127.80. So you can take it. Okay, let's give it. Okay, I'll just making this one. It's a 160. Okay, and the total height is 269. This one. 269. And let's make it. This one is here in 141. 141. Okay. 160 and this total length is 26294. Little bit. You can take 269. Okay, that's it is required here. And then just rotate it and check the smart dimension. Just rotate it. So we have to use another side as well. So let's make it another side because it has already taken the given nominal dimension. So let's make it. I'll just going for the mirror, and here it says that select the mirror entities which is required, this one and this one. These two are required. Also at this side, this one is a symmetric profile, so easily you can take it. About axis, which one? I will expand this one and I'll just choosing the plane. So if I'm taking a top plane, as you can see here, as you can see here, it is showing the preview, the yellow color profile here. Okay, and then go for okay. Okay, still it's under constraint. So I'll just making this one is a symmetric. This one, press control, this one should be, I'll just making a parallel. And now as you can see how it constraint. Okay, done. This wireframe has been done. So what to do the next will be, here is a profile we have to connect here. Okay, let's go for the next here, which is given here also. It's connected here, this one and this one, we have to make that one. So simply zoom in. Okay, simply take a line which is connected from this joint to this joint. So it's not required to fully constrain, automatically constrain. Okay, then let's go for make a line. Okay, I'll just taking a random line. Okay, then I'll just making this along the x-axis, sorry, y-axis. Go for here and take it y. Okay, it's a straight, but the thing is, okay, reduce the size of it, zoom in. Okay, and then make it, press control, this one should be coincidence, select the coincidence, and but this should be here, this side. Reduce this one. But I need a symmetric profile, so you can take a one thing. I'll just making this bottom and this exactly on middle, we have to take a one line. So you can make it from here to here, this one a straight line. Done. Then I can give the distance from there here to here. Okay, it's a degree taken, na? So it's not required a degree, that should be a straight line. Close it, delete it. Only it will be taking your time to make the wireframe, otherwise it's easy to make it, give the structures. Uncheck it, select, and which axis is required, z axis, na? So just again click on that, make it along z. Okay, fully constrained. Okay, now give the dimension which is from here to here. How much? you can take it 845 divided by 2. 845 divided by 2. Okay, done. Restricted. Okay, is it done? I think there is one more line here. Okay, here it's required exactly on mid or one more line. So I'll just making a line. Just take a line here, exactly from here, center to up to second line. From here to here. Okay, done. Okay, one more line from here to here. Okay, almost done. So now we have to add the cross section. So it's required to add the cross section. So let's add the cross section. So one thing, just mark it here, and we are calculating all the dimension from this, that material is inside, added inside, and here it will be a upside. Okay. And this one will be right side, upside and right side. So just mark on it, and we are just giving the uh, profile here, add the cross section. So let's go for maximize. Is now it's not required to give the uh, wireframe. So let's go for, now we are just adding, and after considering the profile, zoom in. Now the time to add the cross section. So we are going for the weldment. So we can use the feature option we can make it, but it will be taking your time. So here is the advanced option is a weldment option. Select the weldment, and but these things are not visible here, which is required to exit from the sketch. So here is first exit from the sketch. Okay, now it's activated, now it's visible. So just go for the structural member, select the structural member, then after a few seconds it will be appear at this kind of uh, specifications where we are giving the profile. So what to do? So here is the ISO standard. Expand it. There are NSI inch, AS, BSI. So there are different types of standards are there. So which standards is following your company, that depend upon the company. And nowadays, and but as a Indian, maximum and most often using the ISO standard. So let's go for the standard, expand this one, and here you can define here the different angle iron, C channel, pipe, rectangular tube, SB beam, square tube. So now I just required rectangular tube. Select the rectangular tube, and also it's required the size. So you have to define only size which is available in your market. Only that standard values are visible here. So if it is required to modify, also you can modify, and also you can create your own standard of your cross section. No issue, you can create it. So we are just going for the which is available in a market, and which is using in a electric vehicle. So we are just taking this one 16 to 40, which is 3.2 is a width of it. 3.2 is a width, and just go for the group, and we have to define the group. Just go for the group, and here we are just giving the group here. So that group means we are just using the structures where we can add the structural members. So now let's see, I'll just using this one. After a few seconds it will be loaded here, the cross section. Now as you can see here, we are required a pipe like a structure, which is a type is rectangular, and the size is this one. So now as you can see, and see the magic, how quickly you can make it. Only it's taking your time to make the wireframe of the profile. Now as you can see. Okay, so not only we are just making here, as you can see there in a drafting sheet, it was calculated the dimension from the last edges, so we have to shift the edges, and that profile should be inside it. Also you can manipulate that one. Okay, so let's in a group one, we are just initially we are manipulate, and just here is a locate option, select the locate, and which side. So I'll just giving, it should be a upside, so I'll just taking this one. Now as you can see, if I'm taking a this one, see, from the front view it has like this one, and top view that should be inside, isn't it? My wireframe, and it was calculated the dimension from end to end, so material will be a inside of it. Is it satisfy your requirement? Done. Then what to do? And if I'm using, if I'm using this one, this cross section, it's not possible. It it can't accept, SolidWorks can't accept, so only it's taking a linear line which will be making a profile, only a single group wise. So I'll just giving this one, zoom in again, and here I'll just using this one continuous and the required, so just click on that, it will be taking now as you can see, and just go for here. Okay, so how quickly and how effectively, efficiently your connection will be done. Connection has been done. Now as you can see, there is no require any kind of calculation, cutting, trimming, nothing is required here. Now as you can see, this one is my requirement. Okay, when your just please mute yourself. Okay, and now the automatically, and the manufacturer will automatically taking the distance from here, cutting the profile, then join together. That is a manufacturer work there, not ours. Only we are making a virtually making a chassis. Done, this one is done. So if I'm taking this side, so it will be a taking a that side, right side of the profile. If I wants to create, no, I can't take it. So I will take, I would take a another group. So here is a new group, at a time you can join here, go for the new group, and same cross sections, same type of the same size of the profile we can add here. So again select it same way. By default it has taken the center of the cross section, but it's not required the center of the cross section. Again expand it and shift the location. Also you can manipulate and the orientation angular direction you can make it, but it's now still it's not required here, I will show you. And go for the locate profile, and now it's a highlighted, I'll just taking this corner. Now let's check it, is it satisfying our requirement? I think yes. Now as you can see, inside of the material is added, and it's a upside. Done. Then same way, just add the collinear members, just go for here, adjacent members, just join the adjacent members. Now done. Okay, now two sides longitudinal beam has been done. Then we have to add the these cross sections. So here how easily and how quickly you can make it. See, that's why it is a user friendly software. User friendly software, and any beginners can easily learn it. Okay, then go for here again the new group here, and I would like to take these all, but it's not possible to take at a time, so let's get it, take it one by one. This one, and also it's taken the, by default it will be taking a center, but it's not a center, and now as you can see it's out of my profile. My profile is not giving this kind of profile, so again we have to change it. Go for the location, change this upside location. Now as you can see, is it taken? Yes, is it taken? But as you can see it's not maintained a proper, because my cross section is this one. Now as you can see, here is my profile and it's giving the extra. So is it required extra? No. So you can give it. I'll just giving the 90-degree rotation of the orientation. So it will be changed. But it's one side. So I'll just giving again 180. Okay, let's give it 270. Again, change the location is this one. And now as you can see, is this our requirement? Now see, is this our requirement? Yes, this is our requirement. So you can, based on that, you can take these are. So let's take it. Same group you can add same thing. It will be added here. Now as you can see. Okay, let's check it again. To time we are just need to check it. Is there any confusion and is there any unexpected things? We will delete it. Okay, it's clear, done. Then we have to add here as well. So this one upside. So it's I'll just taking a one more new group. Okay, again take it here. Okay, the same way you have to recognize, is it perfect or not as per the given data, is it okay or not. That looking is matter. Okay, so you can change the location of this profile, go for the locate profile and here change it. Okay, if it is required inside, no, it's not required inside, should be outside of it. Okay, done. Okay, done. Then we have to take a one more new group which is adding this side and just go for here, select it and let's take it. Okay, now is it satisfying your requirement? I think yes. Okay, it's not required, it's the center, no need to change. So let's go for it. Okay, this one as well. Okay, now this middle portion has been done. Okay, only these two are left. Go for the again new group. Okay, let's check it here again. Is it taken? Yes. So let's change the requirement. Make it. Change it 45-degree. Okay, change the location. Okay, now it's satisfying. Just decrease the angle. Okay, increase the angle. Please mute yourself. Okay, done. So now it has been done. Now it has connected perfectly here. And same way we have to connect here, but that will be another group. Select this one. So let's click on that. Okay, let's connect and go for here. And we have to change the location of it. Please mute yourself. Okay, now it's satisfying your requirement. Done. Then you can take it. Okay. So after adding this one, so we can't take this one. So this cross section is a little bit thicker than this cross section. So we are using one more structural member. So let's go for okay. Okay. Now as you can see how quickly added as per the requirement. Okay. Most of the things are completed. Then we are just making a this one. So again we have to take, because we are using a different size of the cross section, so we can't take along with, so we just need to take another structural member. Just go for here, structural member, and I'll just using this one square tube, and change the size which is available is 14 to 40. Select this one. So let's go for the group members. Again choose it here, this one. Okay, so let's check it. Change the position, locate profile, change the position. Okay, done. Okay, now you can add the adjacent. This one, this one. Done. So if I want to add here, no I can't. So again go for the new group. Again choose it. The same way you have to change the location, locate profile. Which one? This one. So let's check it. Okay, done. Then again inside there, just take it here and here. Done and okay. Okay, done. Then you can apply the sheet over here. So here is a profile, and now it has done. So only this one we have to make this one. So you can apply the sheet over here. The same way you can make this one. So now I'll just making the sheet over here. So this is user friendly. Now again its point is added, and it's satisfying that point is a user friendly software. So how the user friendly software? You can make your profile and add the sheet metal. Now we are in weldment, so also you can jump into the sheet metal. So let's go for click on the face. I'll just using the sketch on it. Go for the sketch. So using this sketch, I'll just making a profile here. Okay, so now this is my profile, and let's go for here to add the sheet metal. So I'll just directly jump into the sheet metal. Here is a edit the base flange where we can add the sheet metal, and the sheet metal means you can that's where we can consider that one is a sheet metal. The sheet metal where the thickness will be 0.5 mm to up to 6 mm, you can consider that that thickness of the profile, consider as a sheet metal. So we can take a 2 mm thickness of the profile, and which side is it? Upside. Give the reverse direction upside, and okay. Now as you can see, just hide the sketches, and now as you can see, okay, how quickly it has done, easily done it. Okay, so now you can make any kind of complicated cross section, any kind of complicated profile you can easily make it. So only it's taking your time when you can make a profile, align the direction, give the dimension, proper dimension, so that you can make it any kind of profile. After that it will be easy to add the sheet metal cross section. It's very easy. So hope you are clear up to this.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So now, okay, thank you. So now this is all about our today's session. So